Hello everyone. Today we're going to be starting the trig section of Honors Math Analysis. We're going to talk about different ways to measure angles and degrees, and we're also going to talk about two types of special right triangles. This should basically be a review from geometry, but let's just see what you can remember. Angle measurements. We measure angles in degrees and radians, but for now we're just going to stick to degrees, which you're more familiar with. Most of the time, angles are measured to the nearest degree. However, there are times you want to write a portion of a degree. There are two ways to do that. You can do it as a decimal, like 34.567 degrees, or you can do it in degrees, minutes, and seconds. So this would be 34 degrees, 11 minutes, 22 seconds. So we're going to practice converting between decimals to degrees, minutes, seconds, and back again. To convert decimals to degrees, minutes, and seconds, since there's 60 seconds in a minute and 60 minutes in an hour, or in this case a degree, we're going to multiply the decimal by 60. And we're going to write the whole number as the minutes, then we're going to multiply by 60 again and multiply the whole number by seconds. You could also have a decimal number of seconds, but for our purposes, we're going to round to the nearest second. So, let's try this. The first thing I'm going to do is I'm going to write 33 degrees, because the whole number of degrees isn't going to change. Then I'm going to take my decimal, 0.4567. I'm going to multiply it by 60. And that's going to give me 27.402. That means the 27 is the number of minutes I have. I still have 0.402 left over. So we're going to multiply by 60 again. 0.402 times 60. 24.12. So that would mean that there are 24 seconds. Really there's 24.12 seconds, but we're going to round to the nearest second. So there is the same angle in degrees with decimals to degrees, minutes, and seconds. Well, how about going back? Again, we're going to write the degree first, the whole number. We're going to divide the minutes by 60 because there's 60 minutes in a degree. We're going to divide the seconds by 3,600 because there's 3,600 seconds in a degree. And then we're going to add them together and we'll round to 4 decimal places. And we're going to do this all at once. So, 14 degrees, 23 minutes, 47 seconds. Let's use the calculator to do all that at once. So, 14 degrees plus, let's put a fraction bar in here, 23 minutes out of 60 in a degree, plus, let's put another fraction bar in. There's 47 seconds, and there are a total of 3,600 seconds in a degree. By doing it all at one time, it makes it easier. Okay? I got a fraction answer there. That really doesn't help me, does it? So, let's go math. Let's go back to alpha y equals. Alpha y equals. And let's change from degrees, or from fractions to degrees. And there it gives me an answer. So, we knew it was going to be 14 degrees anyway, so it's 14.3964 to the nearest 4 decimals. So, degrees and decimals to degrees, minutes, seconds. Degrees, minutes, seconds, back to degrees and decimals. We're going to spend a lot of time talking about solving triangles. To solve a triangle means to find all the given information about it. There's 6 pieces of information for a triangle. You have 3 sides, you have 3 angles. We need at least 3 things to find the other 3. We're going to start with special right triangles, then we're going to go to all right triangles, and then we're going to go to any triangle. Let's start with the 2 special examples of a right triangle. In class, we're going to talk a lot about this, but for this video, I just wanted to give you the basics. This is what's called a 45-45-90 right triangle. It's also called an isosceles right triangle. Anytime you see a triangle that has a 45-45-90 right triangle, these 2 sides are the same. It makes sense because they're across from identical angles. The hypotenuse is always going to be x times the square root of 2. you'll have problems like this where I'll give you one of these three sides and you'll have to find the other two. Just remember, these two are x and this is x squared root 2, and we'll use that to solve. The other kind of, well here, let's try this. Solve this triangle. I need to find x. Well, I know the hypotenuse. The formula for the hypotenuse is x squared root of 2. So now I just need to solve for x. X squared root of 2 is equal to 7. So x equals 7 over the square root of 2. I want to rationalize my denominator. I don't want to leave the square root in the bottom. So I'm going to multiply top and bottom by square root of 2. If you do that, you get 7 square root of 2 on top. On bottom, you get square root of 4, which is just 2. Nothing reduces, so that's your answer. That means that each of these sides is 7 square root of 2 over 2. "45, 45, 90 triangle. You have to memorize that. The other special right triangle is a 30, 60, 90 triangle. In a 30, 60, 90 triangle, the side opposite of the 30 is what we're going to call x. Across from the 60 is x squared of 3, and across from the 90-degree angle, the hypotenuse is 2x. So x, x squared of 3, 2x. Let's solve a problem doing that. Solve this triangle. I need to find both x and y. Well, the side across from 30 is already x. I don't need to call it x. The side across from 60 is supposed to be x squared of 3, and this side is supposed to be 2x. Let's use this side to figure out what x is. I know that x squared root of 3 is equal to 5. That means x equals 5 over the square root of 3. If we rationalize our denominator, we get 5 square roots of 3 over 3. So this side becomes 5 square roots of 3 over 3. This side, the y, is just twice that. So if I were to multiply that by 2, I'll get 10 square roots of 3 over 3. And now I've solved my triangle. I found all the information that was missing. Okay? The special right triangles you have to memorize. The ratios will stay the same. That would be on the no calculator part of a quiz or test, so you have to know these.